Alright guys, so we're back with a couple more applications here. I want to find the area outside r equals 1/2 and inside r equals cosine theta. So I've gone ahead and graphed these. This circle here is r equals 1/2 and this circle here is r equals cosine theta. Okay? And the area I'm looking for is between that line and that line. And the easiest way to see this is to actually graph this with technology. Use your graphing calculator, make sure you're in polar mode, and go ahead and graph these. Now, once I've graphed these, the other thing I have to do is I have to find these intersection points. Now, to find these intersection points, I'm going to make your life really easy. You're going to set this equal to this and solve the equation. Where is cosine theta equal to 1/2? And what you're going to find is you're going to find that this occurs at theta equals pi by 3, and this occurs at theta equals negative pi by 3, quadrant 1, quadrant 4. Okay, so theta equals pi by 3 and theta equals negative pi by 3. So we're going to find those 2 points. Now that we have those 2 points, we want to find the area from here to here. And the way we're going to do this is remember the area of a function with an inner and an outer radius is going to be 1/2 times the integral of a to b, integrate from a to b, of f of theta squared minus g of theta squared d theta, where f is the outer radius and g is the inner radius. Okay, so the outer radius is going to be r equals cosine theta, and the inner radius will be r equals 1/2. And so this becomes 1/2 integral, and we're integrating from negative pi by 3 to positive pi by 3. So this will be negative pi by 3 and positive pi by 3, and it's going to be cosine theta squared minus 1/2 squared d theta. Okay, and so then what do? Well, that's just cosine squared, and that's just 1/4. And so what I end up with is I end up with the integral of cosine squared minus 1/4 times 1/2. So that becomes, right, if I integrate cosine squared theta, the integral of cosine squared theta is theta by 2 plus sine 2 theta by 4. And then the integral of negative 1/2, right? The integral of negative 1/2 squared, which is 1/4, is going to be theta by 4. Okay, it's going to be theta by 4 if we integrate with respect to theta, because basically it's like integrating a constant. Okay, and that's going to be minus. Okay, so minus theta by 4. Now I'm going to cheat. Instead of integrating from negative pi by 3 to pi by 3, right, because there's a symmetry here, I'm going to say that this is equal to 2 times 1/2 integral, right, and it's going to be cosine squared theta minus 1/4 d theta. And instead of integrating from negative pi by 3 to pi by 3, I'm going to multiply by 2 and integrate from 0 to pi by 3. Okay, so I'm going to cheat here. What happens is the 2 and the 1/2 would cancel. So that's why that's going to go away. Okay, and that's going to go from where? 0 to pi by 3. Cool. Now what does that do for me? Well, what that does for me is my area is now equal to pi by 3 by 2 plus sine of 2 times pi by 3 over 4 minus pi by 3 by 4. And that's going to be this guy. And then minus, and since all of these have a theta, right, that theta is 0. That theta is 0, and sine of 2 times 0 is 0, so that's all going to be minus 0. So by using this symmetry and multiplying by 2, I get to save myself a little heartache and a little hassle. If you do this the way I had it set up originally, you're going to get the same answer. Okay, same answer. Just going to be a little more math involved. Well, pi by 3 by 2 is pi by 6. So that's pi by 6. Okay, 2 times pi by 3 is 2 pi by 3. Well, the sine of pi by 3 and the sine of 2 pi by 3 is the same number. That's the sine of 60 degrees, which is root 3 by 2. So this will be root 3 by 2 by 4, and then minus pi by 3 by 4, which would be minus pi by 12. Okay, so minus pi by 12. So pi by 6 minus pi by 12 is pi by 12. So pi by 12. Okay, off my screen here. Let me slide up just a little bit. So that's going to be pi by 12. Okay, and then root 3 by 2 by 4 is going to be plus root 3 by 8. Okay, so it's going to be something like that. Pi by 12 plus root 3 by 8. Okay, something like that. All right. So anyway, that is that's how we find the area between two curves, right? It's just got to be outer radius minus inner radius. And the big deal is not to get lost in these signs, right? So when you minus that, right, you got to make sure that minus follows you through the whole problem. But one exception, of course, is if you're evaluating from a negative, then that minus becomes a plus, okay? So anyway, that is our answer to that one. And we're going to try one more. All right, so here's our other one. We want to find an arc length. We want to find an arc length. And remember, if you go back to the first video, I derived the formula for arc length. Let me write it out for you again. Arc length in polar coordinates is going to be the integral. It's going to be from A to B, integral from A to B of the square root of f prime of theta squared plus f of theta squared d theta. Okay, so we've been asked to find the arc length of r equals e to the theta. R equals e to theta for theta equals 0 to 2 pi. For theta equals 0 to 2 pi. So what that means is our arc length formula will become 0 to 2 pi integral 0 to 2 pi square root of, now remember, what is r? R is always f of theta. Okay, so f of theta is going to be e to the theta. So this will be e to the theta squared. Is what's going to sub for f of theta. I need to find f prime of theta. F prime of theta. Okay, so f prime of theta. Well, what is the derivative of e to the theta? F prime of theta, the derivative of e to the theta is e to the theta. The beauty of e to the anything, right? Derivative of e to the x is e to the x. Derivative of e to the theta is e to the theta. So f prime of theta is e to the theta, and guess what we're going to do? We're going to say e to the theta squared, right? This is e to the theta squared. Well, you get e to the theta squared plus e to the theta squared. That is equal to, let me come down here and keep this going. That is equal to the integral from 0 to 2 pi. Now, I want to give you a quick note. E to the theta squared is equal e to the 2 theta. That's equal e to the 2 theta. So I get e to the 2 theta plus e to the 2 theta. Okay? Fair enough? Which is 2e to the 2 theta. 2e to the 2 theta. Or another way to write it, okay, another way to write it is square root of 2 times the square root of e to the theta squared. Now what's going to happen, this is a constant, I'm going to bring it out, and e to the theta squared, take the square root of that, right, and this of course is d theta. I should copy my d thetas here, missing a few of those. We get root 2, 0 to 2 pi, e to the theta d theta. Okay, cool. Well, what is the integral of e to the theta? Lucky me. It's going to be e to the theta evaluated from 0 to 2 pi. Okay, that's it. So it's root 2 e to the theta evaluated from 0 to 2 pi. That's going to be equal to root 2 times e to the 2 pi minus e to the 0, which is equal to root 2 times e to the 2 pi minus 1. Okay, that is the arc length of e to the theta. Okay, so e to the theta. And that's how we use our arc length formula. And the only complication, of course, is trying to get rid of this radical. So you might have to do some algebra and play with getting rid of that radical, but that's how we use our arc length formula. Okay, so we've got two curves, and we've got an arc length here. Great examples for you to follow. If you have questions, reach out and let me know. Be glad to answer them. Thanks, guys, and have a great day.